2005 Chevy Trailblazer, 4.2 liter engine. The trouble code that I want to address with you guys is this P0106 MAP or BARO pressure circuit out of range. We're not going to worry about the insufficient time for closed loop or the coolant thermostat. Both of those indicate potential thermostat codes. We're just going to focus on the MAP sensor trouble code for this video. Okay, so what I've done so far is I went on Mitchell and I looked up the P0106 trouble code. It's a flow chart that's going to guide us as to what can cause this particular trouble code. P0106, you see at the title up here. I'm using this opportunity to review a section in my book, Pressure Sensors, and there are some testing procedures that I'm showing that are certainly different than what we're seeing in this flow chart. And really, truly, we need the flow chart to guide us. Even though we may know how to check a MAP sensor or a pressure sensor, we need a flow chart to guide us as to what the potential causes are of this particular fault code, because they can be different from vehicle to vehicle. So we're going to compare this flow chart to what the Snap-On Troubleshooter tells us to do on this particular vehicle. So this is actually going to be a little bit of a heads up into the Snap-On Troubleshooter as well. But let's start with this flow chart. So we have a MAP sensor. It says response to pressure changes, gives you a nice little intro, stuff that we've talked about in class for sure, 5-volt reference, a low reference, and then a MAP signal circuit. This next part down here, so I'm looking right here, is going to describe how the MAP is used as a BARO sensor, key on, engine off, wide open throttle, and signal voltage and how it reacts and changes. And then as we continue to read, one of the things we don't want to do with flowcharts is to read too fast, because there's actually one statement in this whole thing, and we're going to come back to it. And it's right here. The PCM calculates a predicted value for the MAP sensor based on the throttle position and the engine speed. I want you guys to remember that, because this is going to be key to this diagnosis, that it compares throttle position, manifold pressure, which is the MAP sensor, and engine RPM. So as we go through this, it tells you about conditions for running the diagnostic trouble code. In other words, it's telling you what engine speed and load and RPM it has to be. And that's not as important to us as some of this other stuff. That's just giving you the engine parameters. So if you wanted to recreate this trouble code, this stuff in here would be helpful, so you know how to drive the vehicle to recreate the trouble code. And that's where you might use information like that. You know, RPM between 600 and 6,000 RPM. I mean, that's helpful to know that I can pretty much drive it at any RPM I want to on this engine. But there might be certain trouble codes that say, you know, it's below 1,500 RPM only, and that would help you in trying to recreate the fault. So just a little insight on this flow chart. By the way, I want to emphasize here that this would be a recreated flow chart from the manufacturer. So this isn't necessarily Mitchell's flow chart. Mitchell's going to get the information from GM and then write down and record with their permission this information for us. So that's kind of where that part's coming in with this flow chart, the information that's here. Actions taken is it sets a check engine light or sets a trouble code, and then talks about freeze frame data and things like that. Conditions for clearing, not worried about that. Test description, this is helpful. When you're doing flowcharts like this, it helps to have a reference to what they're asking you. And there's some steps in here that I think we're going to have to go back to that's going to help us, especially because it's really weird, some of the test procedures. That's what these numbers are. So let's say you're doing step 4, and you're not really sure why you're doing step 4 in this flowchart. It tells you a little description of what that step is and what you're actually doing and measuring. So I want to walk you through this chart real quick. It says, did you perform the system check? And that's just dealing with check engine light, what codes you're having, and things like that. The next one, it's a good one. Inspect for visual components. Make sure it's not disconnected or anything like that. Make sure you have a good vacuum source and there's no vacuum leaks in the engine. The next part, and of course, as we continue through this, we kind of have a yes/no. So the This middle column, just pay attention to this on the way down. This is the yes column all the way down. This is the no column. And so dependent on the result of that test, you would either skip the next step or you would go to whatever they have listed there, whether it's yes or no. And then, of course, this column is what you're looking for when you do your test. So keep that in mind as we continue down through this. 3 talks about using a known good vehicle and comparing, which we don't have. And so again, this is our yes column, this is our no column, and this is what we want to have when it gives you values. So we don't have a vehicle we can use. So what we would do is skip step 4, go to step 5, because we can't do that one. Step 5 has us do our altitude versus barometric pressure. And then what we do there is we click on the table and we look at our comparison. All right, so we have the key on, the engine's off. We're looking at our MAP, kilopascals, KPA, and we're at 98. And so that matches where we should be as far as altitude and what our MAP sensor voltage or converted pressure reading is. And so all this step really is telling you is that this MAP sensor is recording accurately our surrounding pressure. And so if it records your surrounding pressure accurately, it should record the other pressures accurately, and that's what you're doing in this step. So what we found is that it was reporting accurately, and that tells us our MAP sensor is at least able to, again, read our surrounding pressures. So we continue. Step 6 has you start the engine, and a typical MAP sensor test is going to be that MAP sensor pressure should change. And, you know, it goes through a lot of different tests that you can do. The next one is having you use a hand vacuum pump, and this is the calibration test that I mentioned in my book, that you can take a hand vacuum pump and a voltmeter, or take a hand vacuum pump and a scan tool. And what this is telling you, this is kind of nice, is apply vacuum to the map with 1-inch increments until 15 inches is reached, and then it's telling you that each 1 inch of vacuum should decrease the MAP sensor pressure by 3 to 4 kPa. And so we can watch that on the scan tool, and that would be a calibration test. That's a very nice test. Most of the time that's not needed, though, if you have a MAP sensor that's reading a normal idle voltage, which we have on this map, or you can use the specs I use, which is around 0.5 volt to 1.5 volts typically on a map. If it's reacting like that, it shouldn't be setting a map code. Going a little further, after testing the map, they have you doing some other things. Cam timing, tensioner, exhaust restrictions, worn piston rings. All of those are going to affect engine vacuum. So if engine vacuum's low, you're going to have a map code. That's basically what that's telling you. Continue on from there. If you're not seeing a problem there, it's having you do intermittent conditions. And then when we do intermittents, we do wiring checks, we do circuit integrity testing, and really, to make a long story short, on this whole process, nowhere in this flowchart, this is what I want to emphasize, does it say anything about the TPS. I'm going to go back to the beginning. I told you guys that what I wanted to do was emphasize, I wanted to emphasize this right here. What's the computer going to use to calculate whether or not this MAP sensor is doing what it should be doing? It's looking at RPM. It's looking at throttle angle. Let me take you back to the scan tool for a second now. Okay, so I want to take this opportunity to put a plug in for Snap-on. And a lot of people want to know why I choose a Snap-on scan tool over other aftermarket scan tools. Now, I don't want to get into a debate on who makes the best scan tool, and you certainly can't beat a factory scan tool that's designed to function on that vehicle. But when you're in the aftermarket like we are, and we work on 20 different car lines, it helps to have a scan tool that gives you a lot of good info on a lot of different cars. And I want to plug their troubleshooter for a second. So we're going to go down to the troubleshooter on the Snap-on scanner, and I'm going to select code tips. We're going to find our code that we had, which is a P0106. And we're going to read a little bit about the 106. This is going to be in-field kind of help on the same flowchart we just did, right? So P0106 sets when the PCM detects the MAP sensor pressure is not within calculated value. Okay, cool. We know that part already. Excessive carbon buildup on the throttle body and plate may cause the DTC to set or have an idle stability complaint. An idle stability would be like start, stall, stalling at stops, and things like that. And that's it. I mean, there's nothing else in there, but I want to point that part out to you, that nowhere in our flowchart from the manufacturer was that information. And if you followed that through, you may be putting a map sensor in it and not fixing it, and you may be putting a computer in it and not fixing it. So just keep that in mind. Nowhere in that flowchart did it talk about carbon buildup on the throttle plate. Now, we have to add a little bit more information to this to make this make sense. How can you have carbon deposits on a throttle plate cause this condition? I'm going to go back to our engine data, and I want to talk about this throttle body system. This is a drive-by-wire system. And by drive-by-wire, what that means is there's no throttle cable. The computer controls the throttle plate angle for throttle, for RPM and for idle speed. Actually, for everything. The reason I mentioned idle speed is there's no idle air control motor. So this throttle plate is everything. It's your idle control, it's your half throttle, full throttle. Computer's in control of this thing all the time. There is a certain airflow, it's called minimum idle speed, that should be passing through this throttle plate with the throttle plate closed. Over time, it builds up with carbon, and the computer has to open the throttle more to achieve the same RPM that it used to. And so, in my experience on these, let me start this as I'm talking. I'm going to let this warm up for a minute. In my experience with these, you want to have roughly 6 to 10% throttle opening with the engine idling. The complaint from this customer is that he can drive it for 90 miles. There's no drivability problems whatsoever. 90 miles before the check engine light will come back on for this MAP sensor code. So why is this happening? Why is it set in the code? And I believe that Snap-on's got it right, that the reason this code is setting is our throttle body is restricted, and it's causing the computer to have to open the throttle more than normal to achieve a normal idle speed. And so the problem is, you have an RPM that's showing idle, you have a TPS that's showing higher than normal opening. And what's the computer want to see? Remember the three it compares. It compares RPM, TPS, and MAP. And what does it not like? It doesn't like the MAP sensor. I don't know why it's not liking the TPS. Technically, it shouldn't be liking the TPS, but it's setting a MAP code. So now, this is a plug for Snap-on. I have to be honest with you guys. I learned about this. I know about it now, but it was from the Snap-on Troubleshooter where I got this information. I'm at a garage. I got this MAP sensor code on this car, and I can't fix it. And I don't know why. Right? It keeps coming back. Found this little tip in the Snap-on Troubleshooter telling me about cleaning the throttle plate, and that took care of the MAP sensor code. So we're going to do that. I'm going to show you the before and after. We're at 20% throttle angle right now. That says TPDES angle. That's desired angle. That's where the computer wants it to be at. We're at a 620, 600 RPM idle speed, 20% throttle opening. The TPIND angle would be the actual, the indicated angle. We're going to clean this throttle plate, and I'm going to show you how much lower that number is. So remember these numbers: 600 RPM, 620, 20% TPS with a 1.25, 1.24 volt MAP sensor reading. Okay? We're going to clean the throttle plates, see what it looks like when we're done. Okay, looking at the throttle body, it is clearly dirty. And this is, like I said, drive-by-wire, so one of the things we want to be careful of is making sure that we're going to open this throttle plate manually. We want to make sure that the electrical plug is unplugged, which it is. I have heard, and I am not sure, but I have heard that these things can potentially hurt you pretty bad with your finger in there if the motor decides to be energized while you're cleaning it. So make sure you have these things unplugged. What we're not going to do on this model is spray a bunch of cleaner in there. I don't want to take a chance of it getting inside of this motor unit. We're just going to put it on a rag, spray some some carb clean on a rag. We're going to open this throttle plate up manually, and we're going to clean the bore area very well and then put it back together. Okay, I want to attempt to get you an after shot here. Go ahead and open that plate up a little bit. And you see what's important is where the ring closes. Go ahead, you can let that go. Where that ring closes, where this throttle plate closes, is what matters on the top and bottom. Now I know that some of you guys are going to give me a hard time that this could be cleaner, but we are not spraying liquid inside of here. I don't want to. We are using a rag and we are wiping the heavy deposits off. We actually used a brush and scrubbed it a little bit too, but primarily the rag to wipe it off. We did not spray excessive amounts of cleaner for fear of getting it inside of this electrical component. So we're going to put it back together and see the result. All right, so we have the throttle body clean, and I have some scan data pulled up. Can you turn the key on? Don't start it yet. Make sure we're communicating here. And turn those headlights off for me. Okay. And you know, when we first start this, it might run a little funny because we have some carb clean maybe in the intake a little bit, and honestly, more importantly, this thing's going to have an idle relearn that it's going to have to do because we just restored the minimum idle speed, and some cars have very elaborate idle control type relearn procedures. I'm not sure how this one's going to react. Go ahead and start it. I did expect the idle to be initially high. We're at 1,700 RPM. I do expect this number to come down. We're going to let this run and stabilize down to our 620 number, where we were before, 600, 620. So our map voltage is about the same, isn't it? What was our map voltage before? Do you guys remember? Was it 1.24? Huge difference in throttle angle. I have actually a section in my book, in section 20, where we're talking about why a dirty throttle body causes stalling problems. And I have a nice case study in there that deals with this very design, where we have a 20% throttle angle, and when we're done cleaning it, we have a 6% throttle angle. It has a real nice description on why vehicles with dirty throttle plates will have stalling problems. Even though this vehicle didn't have a stalling problem, clearly cleaning this throttle plate restored better control of the idle for this car. And again, refer to section 20 to read that description and why that happens. But now what we're dealing with is a MAP and a TPS reading that is more closely related to what the computer wants to see. So we didn't have any change in the MAP. Notice our MAP voltage is really about the same as what it was, right? We were at 1.2, 1.24. I saw 1.18, but you know, that's really not different than what we had before. I'll have to go back and look. I don't remember what the KPA was. Were we at 32, 33 before? I'll have to go back and look. But now, at the same idle speed, at 600 RPM, now we were around 625, 600, that's pretty close to where we were. We were at 22% throttle opening, and we are now at 5%. So I want to just review something here. Why, first of all, why isn't this information in a engineer-written flowchart? It should be. It's not. Nowhere in that flowchart did it tell you to clean the throttle plate. It did mention, I'll give them this, it did mention TPS, MAP, RPM comparison. So that's number one. Don't like that, but that's pretty typical what we've been dealing with in the field for the last 30 years. And number two would be how much of an advantage was having that Snap-On Troubleshooter piece of information. Snap-On, you know, guys, listen, I'm not being paid by Snap-On to tell you this. I'm telling you from an aftermarket technician perspective that I travel to different garages and make money. And if I can have information like that, that's available at my fingertip, of course I'm going to talk about it. And so I'm just telling you from where I'm at and making money on the side that this tool and that troubleshooter just made me a lot of money today, didn't it? A lot of people want to know, well, should I buy a Snap-On? Should I buy this other product? And I'm telling you what separates Snap-On from every other aftermarket scan tool is their troubleshooter information. That's only one example of many. Guys, think about the process you would have gone through. You would have changed the map sensor, wouldn't have fixed it. Maybe even went through the whole harness, didn't fix it. Maybe threw a computer at the car, God forbid, maybe threw a computer at the car, didn't fix it. What was it? Dirty throttle plate. I'll keep you guys posted to make sure that this light does not come back on. This is a personal friend of mine. I will know about this vehicle. He will tell me, and I will update you guys on this. I'm calling that a fix. Again, what we're looking at is throttle angle and map sensor voltage are now where the computer wants it to be. So basically what this code would be is a false map sensor code set by a dirty throttle body on a drive-by-wire system that had to increase throttle angle. What the computer expected to see with 22% throttle opening is it expected to see a higher pressure in the manifold, a higher voltage off the map sensor, and it wasn't seeing it. It's really kind of a mistake, if you ask me. I'm not sure why the software wouldn't look at RPM too and know, hey, we're at idle and we're at idle vacuum off the map, and it really should be flagging a throttle position sensor code, if anything. But hey, this is reality. This is the way it goes. So a good one for you guys to learn from.